now it is my pleasure to introduce our first speaker, Kruchko. Naomi, if you could bring up her slide, that would be wonderful. Carol is the President and Chief Mission Officer of the Central Brain Tumor Registry of the United States. Since the founding in 1992, she's been working to improve the collection and reporting of population-based data on all primary brain and other central nervous system tumors. She provides yearly reports, supplements to the Society of Neuro-Oncology Journal and Neuro-Oncology. We are so excited to have her today speaking to us about all of the updates that are happening in brain tumor epidemiology. And with that, Carol, you can take it away.
Great. Well, I'd like to begin by expressing my sincere thanks for the invitation to speak during this first annual UCSF Brain Tumor Center Update Symposium. It is made even more special since one of our first collaborations was with Dr. Mitchell Berger, director here at the Brain Tumor Center. The study was published in Neuro-Oncology in 1999, so we go back a long way. I plan to share with you the efforts and the process necessary to develop the SEER recodes and other documents necessary to collect cases of every brain tumor patient in cancer surveillance. I am passionate about making sure that brain tumors are counted as they are diagnosed at facilities like the Brain Tumor Center here at UCSF. Just to give you some background into the broader cancer surveillance system in the United States, my intent is to show how clinical changes affect all surveillance stakeholders, and these are listed here on the slide. The National Cancer Institute's Surveillance, Epidemiology, and End Results Program, SEER, is the oldest population-based surveillance organization in the US. It started as a result of a congressional mandate in 1971, and this is the 50th anniversary of SEER. So happy 50th anniversary, SEER. It currently reports data from approximately 28% of the US, depending on the specific analytic file used. The Centers for Disease Control and Prevention National Program of Cancer Registries is the result of public law passed in 1992, mandating CDC to collect cancer cases from all US states. It includes incidence data from 100% of the US and survival data from approximately 94%. The North American Association of Central Cancer Registries, NACER, started off as the American Association of Central Cancer Registries in 1992, and then expanded to collect data from Canada. It is the keeper of uniform data standards. These standards guide cancer collection of all cancer surveillance organizations. Now, CBTRUS, like NACER, is a not-for-profit organization, and like NACER, it was founded in 1992. But CBTRUS is the only population-based surveillance organization in the US that targets a particular site, and of course, that's brain and all other central nervous system tumors. We receive data yearly from a partnership with NPCR for 45 central cancer registries, the District of Columbia and Puerto Rico, and access 4 central state registries from SEER. As most of you know, prior to 2004, only malignant brain tumors were included in surveillance collection in the US. This remains the current practice in some countries. The vision of the American Brain Tumor Association to have all brain tumors, irrespective of behavior, included in cancer collection, resulted in the founding of CBTRUS, which in turn stimulated the expansion of brain tumor collection practices. The CBTRUS reports provide yearly incidence and survival data by histology, site, behavior, sex, age, and race ethnicity in the US. These reports are published yearly as supplements to the Society for Neuro-Oncology's journal, Neuro-Oncology. Data collected by the SEER, NPCR, NACER are available in reports. They also have mechanisms for public or research access, and I encourage you to go to their respective websites for access information. Now, in surveillance, implementation can be thought of as a living sculpture, structurally sound and meaningful for the time it is exhibited, but sensitive to dynamic relationships in the real world. For surveillance, this is the dynamic relationship between clinical practice and surveillance requirements. And this presents challenges common to all surveillance stakeholders, including CBTRUS. Population-based sources used to determine patterns by tumor type for incidence, survival, and treatment are challenged by changes in clinical practice. Implementation of clinical practices requires agreements on a primary clinical resource. For all cancers, this resource is the classification manuals known as the Blue Books. For brain tumors, the primary clinical resource guiding their surveillance implementation is WHO classification of tumors of the central nervous system. Now, a big thank you to Quinn Ostrom, who provided this slide. It is our understanding that trends have been affected by both histology classification and grading criteria. The sharp decline in the oligoastrocytoma begins at a time when IDH1 and IDH2 mutations and 1p19q co-deletion were coming to be understood as the hallmark molecular features to stratify the lower grade tumors. The 2016 WHO solidified this by removing these tumors as an independent histology. For the embryonal tumors, overall using CBTRUS data from 1998 to 2017, there has been little change in incidence. The medulloblastomas have remained relatively stable as well. It will be interesting to look at these tumors when they are classified as separate histologies according to their molecular signatures, and this will happen with in our next report. The PNET diagnosis has been decreasing and the ATRT has been increasing, but I think we need some clinical expertise to look at these. This slide comes from a CBTRUS publication in 2015, and it shows clearly the influence of the WHO classification on data trends. And I'm going to paraphrase from this publication. The temporal trends shown for grade 2 and grade 3 meningioma represent progressive adoption the 2000 WHO guidelines provided. This classification change would shift the subset of cases featuring brain invasion without histological anaplasia from WHO 3 to WHO grade 2 or 1. In 2007 WHO, there was a small modification, meningiomas having grade 1 histology, but with microscopic brain invasion moved into the WHO grade 2 section. This may have contributed to the continued increase we see in the figure for grade 2. Then came along 2016 WHO. Implementing the 2016 WHO into cancer surveillance of brain and other CNS tumors felt like the sculpture analogy I mentioned earlier. An exhibit moved from a Chicago museum to Antarctica one. And in 2000, and we also know that 2021 is coming soon. We'll hear more about this from Dr. Perry in a few minutes. The steps listed to implement the 2016 WHO into cancer registration practices included CBTRUS petitioning NACER in 2017. Now remember, NACER is the keeper of the uniform data standards that guide all cancer surveillance practices. So we petitioned them to include the 2016 classification histologies. The NACER Uniform Data Standards adopted the 2016 WHO's classification. But I left out, in between that step, a working plan was developed. We worked with NACER on that, beta testing the plan, and then the adoption was finally finalized. CBTRUS began revising its histology grouping based on 2000 and 2007 to 2016 WHO histology groups in 2017. We are just about finished with that. SEER collaborated with CBTRUS to develop an updated recode for specific histologies found in 2016 WHO. Now, these efforts resulted in the new SEER recode replacing SEER histology recode brain grouping, that's how it's listed on the file, with SEER brain and CNS recode. And this is fully implemented and available to researchers now. The recode files incorporate diagnostic categories listed in 2016 WHO into the SEER data available to researchers. It is fully implemented in the SEER data. A subset of the new recodes is available on the SEER online program entitled SEER Explorer, and the URL is there. So this table that I'm showing is adapted from the SEER manuscript by Giancarlo Ferrez, published in the December 2020 issue of Neuro-Oncology Advance. The histology groups to which SEER has provided recodes for brain and CNS tumors are listed, and corresponding ICD-03 morphology codes are listed in the next column. And these are found in the 2016 WHO, as well as those histologies which continue to be collected by in cancer registries, are listed by both behavior, malignant and non-malignant, along with cases in the SEER 21 registry's dataset from 2014 to 2017. Now, in population-based surveillance collection practices, the variability in sources for data, community hospitals, comprehensive cancer centers, freestanding radiographic facilities, necessitates including histologies historically included in cancer surveillance practices. WHO classifications may not include these histologies, deeming them diagnostically no longer applicable. But we hope over time and with collaborative diligence, updates to ICD-03 may change this. Now, SEER recode updated a subset of histology groups found in 2000 WHO. This subset also includes those historically collected histologies with ICD-0 codes that I just mentioned, and was conducted in collaboration with CBTRUS. CBTRUS histology groupings have always been based on WHO classification histology groups. They have always had neuropathology collaborations. With the help of 4 neuropathologists, the CBTRUS histology grouping has been updated to the 2000 WHO classification groups. All histology groups found in 2016 WHO will be reported in the 2021 CBTRUS statistical report with data from 2014 to 2016, and that will be published this fall through Neuro-Oncology. The 2016 WHO histologies with molecular markers will be reported for the 2018 data only, as collection began January 1st, 2018. Now, this is just a shot of the steps that we had to do with our neuropathologists. The CBTRUS histology grouping revision to 2016 WHO has been a very challenging process. Each histology was reviewed with us by our 4 neuropathologists. The screenshot is the first page of over 35 plus pages, and you can see we went through each histology, those histologies in 2016 WHO, and those that we historically collect. After finishing that step, step 2 involved preparing a table listing all the ICD-03 codes pertinent to 2016 WHO histology groups in all ICD histology codes, all malignant codes, and all non-malignant codes. Now, this is a draft of the table that we will have in our next 2021 report. Our 4 neuropathologists are currently reviewing the final draft. And as I said, it will be in our 2021 report. However, there was one additional step. It's completed to report these histologies in 2016, found in 2016 WHO, defined by their molecular markers. Some of these histologies were not given unique ICD codes, making reporting under the current surveillance rules impossible. The site-specific Data Item Committee, SSDI, as listed at the top of the slide, whose members represented all the surveillance groups I mentioned in my second slide, developed a new variable which enabled reporting of these histologies. Again, our neuropathology team helped us by providing support for the diagnostic importance of collecting these molecular markers. And this is a one variable that's listed in the NACER dataset and other data sets that describes all of the histologies with their unique unique molecular markers. Now, SEER published the effect its recode would have on trends from the paper I had mentioned earlier. Now we can see there's a continuing of the downward trend for oligoastrocytoma for all ages. Trends for oligodendroglioma are not as straightforward, but are also declining. So this shows you what is happening with that 2016 WHO. So incidence reporting is in a transition time for cancer surveillance. Remember, there's always a lag time between the actual collection and the actual reporting. It's about 18 months to 2 years. Changes to brain tumor collection impacted by 2016 WHO affects incidence trends over time, as we have just seen. Population-based reporting of brain tumors adhere to collection rules which take time to implement. CBTRUS's 2021 report has a histology grouping that is in sync with the 2000 WHO histology groups. Collaborative efforts with surveillance stakeholders ensure clinically relevant incidence data for all primary brain tumors. So in conclusion, changes in clinical practices affect collection and reporting of brain and other central nervous system tumors. Surveillance organizations work to provide incidence that incorporates changes in clinical practices. WHO classifications of tumors of the central nervous system are the primary clinical resource that guides surveillance collection practices. Reconciling clinical practices and surveillance requirements requires seats at both tables. So I'd like to acknowledge the CBTRUS our scientific team, led by scientific principal investigator Jill Barnholt-Sloan, Dr. Quinn Ostrom, who helped with my slides, and to SEER, and to those 4 neuropathologists that I kept mentioning, Drs. Daniel Bratt, Janet Bruner, Roger McClendon, and Tarek Tihan, who's from your UCS team here at the Brain Tumor Center. And to the tumor registrars at hospitals and treatment centers, the central cancer registries, the staff at national and international organizations responsible for setting the standards that guide the collection practices of cancer data. And to the clinicians who provide the information necessary to report brain tumors. Funding for CBTRUS was provided by the Centers for Disease Control and Prevention under a contract, the American Brain Tumor Association, the Sontag Foundation, Novacure, the Musella Foundation, National Brain Tumor Society, the Uncle Corey Foundation, and the Zelda Doran Tettenbaum Memorial Fund, as well as some private and in-kind donations. Our contents are solely the responsibility of the authors and do not represent the official views of the CDC or NCI. I thank you very much, and I guess I will turn this over to the next presentation. Thank you.
Thank you so much, Carol. That was fantastic. We really appreciate you being here today and giving those really important updates.